Hello, welcome. Today we're going to be looking at the rules, the basic rules of differentiation. We're going to be looking at what?
The basic rules of differentiation.
Basic rules. And we have what we call the sum rule, the product rule, the quotient rule, and the function of function rule. Is that clear?
Yes.
We're going to be looking at those rules. And the sum rule simply says that if you have two functions of x, if you have two functions of what?
X.
You know, in the previous class, we are looking at dy over what? Dx, where y is the function of x. Say something like 2 to the power x squared plus 1. Now, what if we have if you have something like, instead of having only 2 to the power x1, you have something like 2x squared plus 1, in brackets, you have another 3x squared minus 1, where this one represents u and this one represents v. You see that these two are all functions of x. Functions of x are any expression that has s in it. So let's say u is this and v is this. That's what we mean when we say given u and v that are functions of x. So if you have them arranged in such a way that they are added, the differential is simply the differential of the first one, the first function, say 2x squared plus 1, plus the differential of the second function, 3x squared minus 1. So when you add them up, if you differentiate them individually and add them up, that is the differentiation of this, and that is called sum rule. Now, differentiation of a constant, given if c is a constant and you have a function of x, the differentiation is simply bringing out the constant to the other side and differentiating the function of s. So this function of s, u, could be this, 2x squared plus 1. So you do the normal differentiation. Now the product rule says that if you have two functions of x that are multiplied together, their differentiation is actually the first function differentiate the second function plus the second function differentiate the first function, add them together. Now we look at the quotient rule. The quotient rule says that if we have the differential of the second function over the first function is simply equal to keep the first function, differentiate the second function, minus keep the second function, differentiate the first function all over the second function squared. Very, very important. You need to know this. You need to know this. The rules are very, very important. The rules are what?
Very, very important.
Very, very important. The rules are very, very what?
Important.
Important. Please, this is u over v. So the quotient rule simply says that differentiation of first function over the second function is simply the first function differentiate the second function minus the second function differentiate the first function all over the second function squared. Now we have what we call function of functions. We have what we call what?
Function of functions.
Or you call it chain rule. It simply means that if you have v that is a function of u already, that their differential is actually differentiation of the function of function times differentiation of the second function all over. That's dv dx. Where v is a function of u. Chain rule, very, very important. I'm going to be explaining this as where is my cleaner? I'm going to be explaining this with some examples. With what?
Some examples.
Some examples. I'm going to be explaining this with some what?
Examples.
Examples. Now, I told us that given y to be equal to ax n, that the differentiation of y with respect to x is simply equal to n a x n minus 1. Is that not what is in your note?
Yes.
That's the first statement. So if you're given an expression y to be a function of x in this way, to differentiate it, simply carry the n. Can you see the n?
Yes.
Bring it to the back. Then subtract 1 from the n. Now, given that y is equal to 2x squared plus 3x, who can tell me the dy over the x of this? It will simply be, can you see the 2?
Yes.
You have to carry it over. So 2 times 2,
4.
X. You have to subtract 1 from the x. 2 minus 1
1.
plus the same thing here. What is here? You know that 1 is here even when you are not seeing it. Goes over it will be what? X. Then you have x. 1 minus 1, 0. So now you have what? 4x plus anything to power 0 is 1, 3. Can you see that? If you are told to differentiate y equal to x3 plus 1, what will be the answer? The y over the x will be equal to what? This 3 will come over, is it not?
Yes.
So I have 3x what?
Square.
Because you reduce 1 from there. Differentiation of a constant is what?
1.
Nothing. You understand? So this is the answer that you have. Is that clear?
So the
constant
plus
is
1 is
anything
not
that does not have x attached to it. Differentiation of it is 0. Is that clear?
Yes.
Now if you are told to differentiate y equal to 4x 3 plus 2x, what will be the answer? The y over the x will be equal to what?
12x
4 times 3 times 2 is what? 12x what? Square
plus
plus
2x
2
x1
x supposed to be 1 minus 1,
0.
which is 0. And x to power 0 is what? 1. So this is supposed to be the answer. Is that clear?
Yes, sir.
And differentiation of cos theta is equal to what? Differentiation of sin theta is equal to what? Check it in your note. You see a place where I drew something like this, and I wrote here the differential.
So that note is not alright.
Okay, we'll update it. What's the differential of cos theta and sin theta? Check. Check the differentiation of sin theta and cos theta. What does it give? Then
Cos
after
x.
checking, you do this assignment. What does it give?
Cos x.
Cos theta, when you differentiate it, what does it give?
That will be cos x. Cos x.
Which one?
Cos x is minus
Or you
sin
say cos x. Cos x gives you what? Minus what?
sin x.
Sin x. While differentiation of minus of sin x gives what?
Cos x.
Cos x. So now do this assignment. Given that y is equal to x to power 4 plus 2x to power 3 plus 3x to power 2 plus 1x to power plus cos x plus sin x plus 100. Who can give me the dy dx of this assignment? Alright, let's go. What's the dy dx of this?
4x
4
x cube
cube, isn't it?
Yes.
Plus what?
6x
6x squared, okay, plus